usually works to get a better accuracy. Okay? And I also can get a kind of probability, okay? Because let's say I have an unknown sample which is predicted negative by 3 trees and positive by 3 trees, then probably that sample is in the middle between the two classes, okay? It can be probably a sample I have to analyze, okay, to better understand. Okay? So I have a kind of averaging or consensus between all the trees. And this makes my prediction. Okay? That's all. These are random forests. Not bad. In half an hour, okay. Do you have questions? I mean, it's not all, but I mean, did you get the point? How does it work? Yeah.
When do I know when to stop with the bootstrap? In the sense, how many?
Yeah, that's the difficult part. So, as we will see it in a few slides.
Yeah.
Okay, this is the algorithm, but this is what we have seen. Okay. So it's not important. Yeah. One thing is that I mean, when if you are familiar, for example, with PLSDA, okay, one important information you get usually from your classification model is the variable importance. Okay, so for example, in PLSDA, you can look at the coefficients to understand which is the most important variable. Okay, to classify your data. Here you don't have coefficients. Okay, because you just have splits, but anyway, you can get information on variable importance. Okay, so you can somehow calculate some weights, okay, for variables that explain you if a variable is important for separation. Okay, it's not important exactly how. Okay, but the fact is that you can imagine. Okay, this is what we have seen before. Okay, imagine we have to classify this data set. As I said to you, this is a data set constituted by 4 variables. Okay, this is one classification tree, just one tree in my random forest. As you can see, I mean, the only 2 variables selected in the nodes are variable 3 and 4. So I expect this variable to be important, right? Variable 1 and 2 are not important because they do not enter in the splits. So I don't use actually these variables for this, to separate the classes. In the forest we have many of these trees, okay? I expect these trees to be more or less similar. Probably in some of the trees, by chance, variable number 1 and variable number 2, they appear. But in few of the trees I have, okay? And I expect to have, in the majority of my trees, these variables. So I can count how many times variables appear in the trees of my forest, and that's more or less the importance I have, okay? And I can give a score, an importance to my variables. Okay, so I have this information. I have this information which can be important if you want to interpret your data set, okay, to understand which are the most important variables for class separation. Okay?
I have a question.
Yeah.
When you split in the bootstrap, when you split the out-of-bulk data,
Yeah.
You said that the remaining ones you duplicate some of
Yeah.
them. Which is the purpose of duplicating these values?
In original bootstrap is to have the same size of the data set. So you train a model with a data set which has the same size of your original training set.
Okay, so you first do the training model and then you do the external validation.
Let's say, okay, you know cross-validation? Okay, when you divide your samples in groups. Okay, let's say we divide our training set in 5 groups. I'm talking about cross-validation now, okay? 5 groups, it means in each group we have 10 samples, yeah, I was checking. Okay, so when I leave out the first group, okay, I leave out the first group, I train a model with the remaining samples. So I train a model with 40 samples and apply this model on the left out 10 samples, okay? In Bootstrap it's different. So I maintain the same size for the data set, okay? So instead of reducing the size, I duplicate some samples, okay? So I get some external samples, and then I have a data set, a temporary training set, which has the same size of my actual training set, okay, with some repetitions. And I maintain the same size for the data set. This is the aim, okay, to not reduce the size of the data set. Oh, this is the aim of doing Bootstrap, at least as far as I know, okay. Okay, this is the question. Now, when you do, when you try to apply these methods, then the critical point is this one, okay? And it will be the same when we will see super vector machines, and it will be the same if we have time when we will see self-organizing networks and neural networks, okay? So the critical point is how you tune, how you select and decide the number of trees, for example, okay? I was reviewing a paper last week, and they used it, I don't remember which method. I don't know, it was probably super vector machines. And they, in the paper, they didn't validate the model accurately, okay? So they say that they used the standard parameters to train the super vector machine, okay? So it means that they didn't select anything here, okay? And that's wrong, okay? Because for each data set, you have to somehow optimize, tune all these parameters, okay? And here, the most important is this one. How many trees you want in your forest, okay? Actually, I don't have, suggestions. In the sense that it depends, okay? If your classes can be easily separated, maybe few trees are enough. Of course, the highest the number of trees, the highest the computational time you need for the calculation, okay? And this can be, in a computational point of view, it can require some time, okay? So my laptop, I was doing some trials last week, and it required for a average data set, like 500 samples, 20 variables, 50 variables, yeah, 1 hour, 2 hours, okay, to do all this optimization. Because if you don't know how to do that, the best thing is to try, okay? So the best thing, if you don't know which is the optimal number of trees, the best thing is to try different numbers and select the number of trees, for example, in this case, which minimize the classification error using a cross-validation procedure, okay? Now it gets a little bit more complicated, yeah. Okay, so when you don't know how to do one thing, you try, right? Okay. So it's a kind of trial and error. Okay, so you try and you see which is the best solution. And we do exactly the same. So we can grow a forest with 10 trees, 100, 1,000, and let's see which is the best one. How can we understand which is the best one? In a classification, let's say, framework. We can look at the classification error. Okay? So the number of trees giving the lowest classification error is the one we want to use. Okay? But the classification error must be estimated with cross-validation. Okay? Not on the pure training set. But I want to select the number of trees which maximize the predictive capability of my model. Okay, so the capability of my model to predict future samples. And I do that with a validation, for example, a cross-validation procedure. Okay? We will see it later, but did you get this point? Is that, have you ever tried to use PLSDA? Everyone, more or less? Okay, when you do PLSDA, you have to select the number of latent variables. How do you do that? In cross-validation, okay? And you select the number of latent variables which minimize the classification error in cross-validation. It's exactly the same, okay? When you do PLSDA, you have just to choose the number of latent variables. Here you have to choose the number of trees. Plus, if you look at MATLAB, okay, at the MATLAB routine for calculating random forest, then there are a lot of, let's say, optional, okay, parameters which have some default values, but these values can be changed. Then it's up to you. But the more trial you do, the more time, okay, it requires. For example, you can define the minimum number of samples in a leaf node. What does it mean? You have a tree, okay? So this is the first node, and then let's say here you have the classes, okay? The leaf node is the terminal node, okay, where you have the classification, okay? Minimum number of samples in a leaf node, it means that you can decide how many samples you want as a minimum to have in a leaf node, okay? One means that you can actually have a lot of splits, okay? For example, in MATLAB, you can decide the number of predictor variables for each decision split, okay? What does it mean? That there are many versions of classification trees, but for example, in this case, when you do a split, okay, each time you get a classification trees, the split is not evaluated on the full number of variables, on the entire number of variables, but every time it selects a random subset of variables to do the split, okay? So you can actually change a lot of things, okay? And of course, this can improve your model, but things get more complicated, okay? For example, when we will use random forest in the toolbox we do, I avoid this stuff. I don't like it, okay? And for example, as a minimum number of samples, I put a value higher than 1, okay? I think the default is 5, okay? Just to avoid, this extreme kind of overfitting. But then, every user is free to change all this stuff, okay? Of course, you have to know what you are doing. Okay, so this is optimization. We will see some examples. Last slide, just an example, okay? This is how I try to do, okay, optimization in an automatic way, okay? So, every time you run a random forest, okay, the results you get is not always the same, exactly the same, right? Because, okay, it's not like PLSDA, okay? When you run if you run PLSDA on the same data set with the same number of Darien variables and with the same data scaling, you will get always the same coefficients, okay? And this is nice, okay? Here, if you grow a forest, okay, with 10 trees, okay, and then you do it again, a new forest with 10 trees, these two forests are not exact, they will be similar, but they are not exactly the same, because every time you select some samples randomly, okay? Okay. So, then, if you ask people, they will optimize random forests in many different ways. What I try to do is this stuff, okay? I repeat 10 times, okay, a 5-fold cross-validation, okay, by varying the number of trees. So, I have my training set. I decide to use, I don't know, 10 trees, okay? So, I do cross-validation, okay, by growing forests of 10 trees. And I repeat it 10 times, okay? And then I average the results. And then I do it not with 10 trees, but with 50 trees, 100 trees, 500 trees, and so on, to see, okay, what happens. Okay, so this is the number of trees, okay? I will try to use, I don't know which data set is this one. And this is the average error in classification, okay, in cross-validation. And these bars, okay, are the variation I have in these 10 repetitions. So can you see when I use a low number of trees, of course, I have more variation in my results. And if I use more trees, then the results have lower variation. But if I look honestly at this error, it doesn't change so much. I mean, it's actually the same, okay? So what would you do? I don't know. I would use, for example, something...
Use PLSDA.
Yeah, probably on data set these days. I would use like 100 trees, which is not computationally too high. Here I have a low variation of my results, so I have like stable classification, okay? I would do this. This is made in cross-validation, okay? Now things get a little bit, I know today is complicated, okay? Another thing you can look at is the out-of-bag samples. Do you remember? We have some samples which are left out, right? So, for each tree in our forest, we take out some out of bag samples, okay? And then with some replication, we have, okay, the training, the temporary bootstrap training set, okay? These are left-out samples, okay? And we calculate a classification tree, okay, with these remaining samples. But we can predict these left-out samples, okay, with that tree. And this is a kind of internal validation. So another way is also to look at this, at the error we get on these out-of-bag samples as a number of trees, okay? And here you have, in the same data set, okay, these trends. So this is the error, the average error on the out-of-bag samples, okay, as a function of the number of trees. And if I see this plot, again, I see that, of course, I would never select a low number of trees, but then, there is no so much difference using 100 or 1,000 trees. Okay? So it's another way to look at, to select, okay, the optimal number of trees. Even if what I trust more is the external is the cross validation I do, okay? Because I'm sure here that samples are left out and predicted, okay? But the best thing is to do a break, I guess, okay? And then is to try, we can try on MATLAB to use this stuff, okay? This is, I think, the very first, or one of the very first publication on random forests. And again, here you have, all the slides, the theory I got it from this book, okay, which is the same I gave you at the beginning. Okay, so let's do, I don't know, 15 minutes break, and then we can, and if you want to start MATLAB in the meanwhile, okay, so then we can do some practical stuff with random forest.